about some rules and facts or basic and principle of the ECG. So, interpretation of the ECG. It's impossible to interpret the ECG if you don't know about the pattern of the ECG. To know about the pattern of the ECG, it is very important to know about these basics and principle of the ECG. First, recording of the electrical activity of single cell from inside of the chest through microelectrode is called action potential. You should know the concept of the action potential and differences of the action potential to the ECG. So recording of the electrical activity of single cell from inside the chest through microelectrode is called action potential. Different parts of the heart have got different action potential or different diagram of the action potential. For example, first is anode. This pattern represents the synodal action potential. In action potential of a synode, we don't have plateau phase of the action potential. So this is 60. This 60 represents resting membrane potential, and this 0 just represents depolarization, and this 3 represents rapid phase of repolarization. This is a diagram of the action potential of the SA node. Right now we come to the AV node. The AV node is a little bit different from the shape is also. So this is also have got the resting membrane potential of 60 and 0 phase and phase 3. The difference between the SA node and AV node, I mean pacemaker cell from non-pacemaker cell, is related to plateau phases of the action potential. Ventricular cells, arterial cells, and Purkinje fibers. They have got the resting membrane of potential of minus 90. So this diagram is represented arterial action potential. In the arterial potential, the plateau phase is present but small. The second one is represented Purkinje cell. Purkinje cell, the 0 phase is very short because Purkinje cell rapidly, immediately, and fastest part of the myocardial tissue conducts. So the depolarization is performed from the Purkinje cell very rapidly. It is made from 4 phases. Phase 4, resting membrane potential, 0 ventricular depolarization or R wave, and slow potassium channel and plateau phase, and finally rapid phases of potassium, which lead to formation of the phase 3. So recording of the electrical activity of the heart from single cell from inside the chest through microelectrode, microelectrode is called the action potential. And the difference between the action potential and difference between the whole myocardial tissues. Action potential have got this type of diagram, but the ECG have got this diagram. Principle number 2, recording of the electrical activity of whole myocardium from outer surface of the body, which are recorded by those electrodes which are attached to the body, and then these electrodes transmit this electrical impulse to the needle of the ECG machine and produces different wave segment interval, which is called ECG. The difference between the ECG and action potential. With action potential, we studied the electrical activity of single cell. Action potential defined as recording of the electrical activity of single cells. This is called the action potential. But when we record the electrical activity of whole myocardium from outer surface of the body, this is called ECG. Right now we will be discussing about the dual chamber concept. What does it mean, dual chamber concept? When we are anatomically speaking, heart is made from 4 chambers. But from the standpoint of the electrophysiology or electrically, it is made from 2 chambers. Because right atrium and left atrium are electrically connected to each other through the gap junction. When these 2 atrium are electrically activated, they produce a single wave over the ECG paper, which is called P wave. Instead, we have got 2 P wave, we have got 1 P wave. What is the reason? The reason a dual chamber concept. What is the dual chamber concept? Right atrium and left atrium are electrically connected to each other through the gap junction. When they are activated, they activated both of them together. So and therefore they produce a single wave which is called P wave. Likewise, ventricle. Right ventricle and left ventricle are also connected to each other through the gap junction. When both ventricles are electrically activated, their activation occurs together. So due to electrical activity of both ventricles, we also have got 1 QRS complex. We don't have 2 QRS complex. This concept is called ECG, the dual chamber concept. This is the reason we have got 12 here, but on ECG we have seen just 1 P. We have got 2 ventricle, but on the ECG we have seen just 12 QRS complex. This was about a dual chamber concept. After the dual chamber concept, we are coming to these illustration or these illustration. Remember, a positive charge, when moves toward the electrode, they produce a positive deflection. It is very important, a positive charge, when moves toward the positive electrode, the deflection in the needle would be positive. This is very important. The second, when a part of myocardial tissue completely depolarized, during this period, just a straight line is produced. And during this period, the heart does not accept further stimulation. It means this is in refractory period. This is another principle. Finally, when the positive charge moves away from the positive electrode, the deflection in the needle would be negative. Positive charge toward the positive electrode, the deflection is positive. When a partial part of the myocardial is completely depolarized, in such a case there is no electrical activity. During this period, just a straight line is produced, and during this stage, the heart does not accept further stimulation. Right now, when this time the positive charge moves away from the positive electrode, this is a negative electrode. When the positive charge moves away from the positive electrode, the deflection in the needle would be negative. Positive charge toward the positive, deflection is positive. Complete depolarization, in a straight line. And when positive charge moves away from the positive electrode, the deflection in the needle would be negative. Another principle, depolarization is started from the endocard to pericard. But repolarization is started from pericard to the endocard. You accept this pericard and this myocard, and this is inside the cell. Repolarization is a negative movement. Repolarization is a negative movement. So this negative move, when moves toward the negative electrode, the deflection in the needle will be positive. Same charge. Same to positive charge toward the positive deflection, and negative charge moves toward the negative, the deflection in the needle will be positive. Remember, in this case, the positive charge moves toward the positive electrode, the deflection in the needle would be positive. But this piece is a small piece. The deflection of this piece produces a small deflection. Right now we have got large part of the myocardial tissue. I think we have got left ventricle. This left ventricle, positive charge moves toward the positive electrode, the deflection in the needle is positive, but strongly positive. That is why left ventricle exerts more influence on the ECG compared to the rest of the heart. So this time positive charge again moves toward the positive electrode, but the deflection in the needle would be positive, but strongly positive. And atrial tissue is a small tissue. It is made from less cell, and they need less sodium. When the electrical activity is produced within the atrial cells, and positive charge again goes toward the positive electrode, the deflection in the needle will be positive, but small deflection. Thicker part produce large deflection, and small part produce small deflections. In addition to that, some part of the myocardial tissue conduct the electrical impulse rapidly. Some part of the myocardial tissue conduct the electrical impulse moderately. Some part of the myocardial tissue conduct the electrical impulse fastly. For example, the Purkinje cell is a cell which is fastly conduct the electrical impulse. So the deflection is present, but rapidly the needle goes and comes down. This is another principle. Purkinje cell is a cell which is rapidly and fastly conduct the electrical impulse. So the needle is fastly goes and then fastly comes down. Ventricular cell is also conduct the electrical impulse rapidly and fastly. Atrial tissue is supplied by moderate conduction system. So they conduct the electrical impulse moderately. For example, slow the needle goes up and slow comes down. Finally, AV node. Before we discuss about the conduction system of the AV node and SA node. Depolarization of the SA node and AV node in the ECG are very important point of the ECG. But unfortunately, we don't have any waves from the SA node and AV node over the ECG paper, because the SA node is very small node, or the SA node is a tiny tissue, and the SA node depolarization depends to calcium. Due to this reason, the SA node does not produce enough electrical voltage which is detected by the electrode from outer surface of the body. So from SI node, we don't have directly any waves or deflection directly, because indirectly we know, because when we have got a well-defined P wave, it means this arterial tissue is stimulated by the SI node. Another SI node.
Slow conduction.
We have talked about the slow conduction. I think it was
also.
Again, we'll once